In this video, we are going to discuss data representation techniques used in project management. Now, back when I learned these things, I didn't know them as data representation techniques. I knew them as graphs and charts. The formalization, data representation techniques. Yeah, how do I take data and graphically or otherwise represent it? Commonly what I see in my classes is depending upon people's backgrounds at least, is they'll be going, okay, why do I, this particular one, what do I do with it? That particular one, what do I do with that? And I guess I was blessed because earlier in my career I did a lot of things with charts and graphs, building a reporting system when I ran a service department, and then 4+ years at Motorola with Six Sigma being drilled in my head at 99.9999998% accuracy or better. That was a little sarcasm, but that was a PM joke. So hopefully I'm going to have some good examples here and, kind of positive, negative characteristics of some of these things for you to help you keep them straight. Now, when we think about a check sheet, basically it's like tick marks. So if you have somebody answering the phone at the front desk type thing, basically they could have a little table like this. Every time somebody calls, they just put a little tick in the respective cell there, and at the end of the day or the end of the week or whatever, they add it up. And then they can see, well, let's see, wow, we got a lot of wrong number. Okay, well, a lot of information requests come in. Oh, the boss why does the boss call on Friday Oh, the boss wants the TPS reports on Friday. And if that made no sense, watch Office Space. You're welcome. Anyway, but a table like this could lead to some of these other graphs being populated, as an example. Now, functionally, what a check sheet is, it's tick marks by count. So, whatever we're measuring, over what time frame, what frequency of them did we have. Now, when we go to flowcharts, first let me say the note on the bottom of the screen there. In quality, it helps with consistency because you do the same thing. In risk, you can use it for opportunities or threats. Opportunities, you could analyze and say, well, here's a possibility to upsell somebody, like a sales funnel. Or here's a threat where somebody could exploit something if we're not careful. So then you could possibly modify this flowchart with risk to possibly realize that opportunity or plug that hole that could be a threat. But what's going on with the flowchart here, it basically is a workflow. So decisions are diamonds. Like a new student, go that way. Not a new student, go this other way. And then ultimately, ship the product, if you will. Now, when we look at a histogram, this shows defect by count, not severity. Count, not severity. So let me emphasize. System down on the left occurred 5 times. Now, if my goal in using a histogram is to know what breaks the most or what gets attention the most, whatever it is we're measuring, whether we're selling a product, what do we have the most sales of, if it's quantity or is it dollars, you got to look at what's being measured. In this case, it's count of defect. So we have a lot of changes requests by stakeholders and data from non-project team sources. So that takes up a lot of occurrences there. So again, if the priority here is what is having the most occurrence, this is a good thing to show that. Severity not showing is a negative characteristic of it, meaning system down, that's a thin bar or a short bar. And I sometimes use in my classes, I'll say, okay, fatal cardiac event. How many of those will you have? Somebody will look at me and they'll fatal meaning you don't survive it. Cardiac event, cardiac is your heart. So translate fatal heart attack. You'll have one of those. And I use that as an example. System down could be a nuclear power plant melting down. Okay, well, this is probably not the best thing to be tracking how often a nuclear power plant would go down. So, so if it's, categorizing your trouble tickets and things like that, this would be a good thing to where you could maybe go, 60% of our trouble tickets are users trying to figure out which printer to connect to, because they know where the printer is in their cube area, but it's not labeled, as far as the network name or IP address or whatever. So you could take something like that. If it's identified here, that could lead to a project to potentially lower that bar, for example. And so again, the emphasis is frequency of count. And note severity is not necessarily shown, meaning, just because it's a shorter bar doesn't mean it's not severe. Now, when we look at a Pareto diagram, this is a cumulative histogram. So the 80-20 rule generally applies. I say generally, a little more ironic sarcasm there, but it's not always the case, but more often than not it is the case. So 80% of your business comes from 20% of your customers. 80% of your defects comes from 20% of your products, as an example. So rules of thumb or heuristics. Now, what you can do with this is similar to the histogram we just looked at, but it's got a cumulative component, which is that diagonal line going bottom left to top right, Freudian slip there. And so where the diagonal line intersects with the top right corner of toner ink empty, that's basically, there's a little bit of an arc there. And then if you basically had pager jam or something, then that there's a little bit of an arc there where if that line started at the height that toner ink empty stopped at, as far as its peak, like if it was stacked on top of it but moved over, and where it's at horizontally, the top right corner of that second bar would be there where there's a little bit of an arc. So if you said, I got to get rid of 60% of my defects, you could take 60% on the vertical axis, draw a line over, and then basically figure out how much can I do to get rid of those first two big bars, as an example. Now, again, by count, not severity. And the diagonal line represents the cumulative percentage. If you basically take where it would intersect the vertical axis to the left, if you will. Now the scatter diagram, I jokingly say in my class, I got this graphic off of Abraham Lincoln's Facebook page, and he said George Washington tweeted it to him. And so what this shows you is the number of brain dumps copied per day and your overall exam score. And you might be going, Abraham Lincoln's Facebook page and George Washington's Twitter account. Yeah, well, yeah, they weren't around, those tools weren't around back then, and PMI doesn't share an exam score either, so all three of those things are nonfiction. But it's a really good example. So here's the deal. If this were accurate, and I'm trying to show this for illustrative purposes, one axis, you have number of brain dumps copied per day. That's vertical. Horizontal, you have the exam score. And so if we could track that, then what this shows, how it's climbing diagonally until you get to about 4 brain dumps a day, and that starts to level off. You could say that there appears to be a direct correlation between the number of brain dumps per day and your exam score going up. So the more you do, the more your score goes up, until you get about 4 a day, and then it kind of starts to level off. Now, you could have the line, not the line, but the pattern go in the opposite direction. So from, like 6 brain dumps a day and 0 on the exam, down to 1 brain dump a day and 125 on the test. Now, if it's going in that direction, yeah, don't watch my brain dump video. But that would imply there's a relationship as well. It's just going the opposite direction. If it's a random spatter of dots, it implies there's not necessarily a correlation between the two variables, if you will. I heard somebody, I've heard more than one person jokingly say this. It's like, the more I drink, the less I care. So technically, you could plot something, you could survey a lot of people and plot something like that out on this, and you could basically say, okay, how many drinks does it take for somebody to not care? And, somebody's dot that's going to be probably way, way, way high up there, you might go, Geez, Sam, you might want to get that looked at, because if you got to have that many drinks to not carry, you might have a problem. Anyway. But again, what it does, it shows if there is a relationship between two variables, and if so, to what degree and what direction it's going. When we look at the run or control chart here, a control chart is a specific form of run chart that we're going to talk about at the end of this. But let's talk about the run chart to begin with. Now, a run chart or control chart shows output over time. So examples that commonly come up in class are things like tracking orders. Like how many orders did we have, by the hour. Well, I'm a business owner. If that's the case, I want to punch a hole in the ceiling of this chart, and I want it to go through that upper spec limit. Now, that's not quite the spirit of how this is intended. Think about it like this. Let's say we're trying to fill a soda can. So, according to this, it's 355 milliliters. Now, the mean maybe is, let's say, 355. And regulatory says we got to be at least 353, and the capacity of the aluminum can won't allow us to go, or let's say regulatory says we got to be 353 to 357. The capacity of the can won't let us go beyond 359 milliliters. So generally speaking, the control limits are going to be some sort of I like to think of them kind of like customer tolerances. So the mean is what we're aiming for, kind of like the middle of the road, and as long as we hit the dashed lines, but generally speaking, we're good. Now, if we get up to the solid lines, those are kind of like the edge of the road, where the dashed lines are like the stripes near the edge of the road. The solid lines are the edge of the road. Well, you don't want to go off the edge of the road. So that's part of the reason they have those stripes at the edge of the road as kind of a reminder, hey, you're getting close. So if we're aiming for the mean, as long as in most cases the data points kind of stay between the control limits, we would say the process is in control. Now, like problem A here, where it's outside the control limits, we would say that data point is out of control. Problem B, where we would say that's out of spec because it's outside the spec limits, we would say that's out of spec as a result. Now, another thing we could have happen is a run of 7 rule violations. So if you are a 6 Sigma black belt or master black belt or something like that, you're sitting here going, oh, Tony, there are so many run rules that could be used. And these are heuristics, rules of thumb. But this 7 run rule basically says if you have 7 or more points on one side of the mean or the other without crossing, it means you have something that warrants investigation. Doesn't mean you have a problem, but it means you have something that warrants investigation. So you want to look into it. So I use the example in class. So I'll say to, if there's somebody kind of big in class, I'll say, okay, George, for example, here's the deal. We're going to play a game. So you got a stack of $100 bills that you've got. I got a stack of $100 bills I have. And I have the coin. And you're a nice guy, so you're gonna let me flip the coin first. And the rule is this: whoever wins, they get to flip the next time, and they get to call whether it's heads or tails. And so theoretically, somebody could just keep flip over and over and over using that logic. But it's my coin. You have a stack of 100s, I have a stack of 100s. So theoretically, we're not going to get nitpicky and go, well, a coin could land on the edge. Let's say the 2 choices are heads or tails. So I flip the coin, I say heads. It's heads. You give me $100. Now, because of our rules, I get to go again. I flip the coin. I go tails. You give me $100, and it's tails. You give me $100. So I'll say to George or whoever, how many times do I have to flip that coin and you lose $100 every time I flip the coin before you maybe want to go out to your truck and get your, well, we're in Texas, before you want to go out to your truck and get your gun or your baseball bat and kind of wave it at me and say, give me my money back. Now, I'm not saying 7 is a good number, but, usually in class after people commonly say after about 3, they'd start going, what's the deal here? What's the trick? Well, 7 data points on one side without crossing implies that something might not be pure random. Something could be, I sometimes say, stuck. And as a result, you might want to investigate it. That could result in an adjustment of something, like maybe your mean, or it could simply be, just a statistical anomaly. But you investigate it, you do the due diligence. If it keeps working like you expect, rock on. Now, a control chart is a little different than a run chart. So let me specify. If I had my control limit set at anything other than plus or minus 3 sigma, so I could say 80% of my data points I expect to fall between the control limits. That's a run chart. 100% I expect to fall between the control limits. That's a run chart. 99.73% or more of my data points I expect to fall between the control limits. That's a control chart. In other words, plus or minus 3 sigma of our data points we expect to fall between the control limits. That makes it a control chart. Kind of like here in the US. Nowadays it's not as good of an example, but back when I started driving and you could go 65 miles an hour on interstate, you knew you were on the interstate if you could go 65. Anywhere else, 55 was the fastest you could go. Now they got all these exceptions and rules, but if it's plus or minus 3 sigma, it's a control chart. So in other words, the dashed lines, I would expect 99.73% or more of my data points to fall between those. Whether they did or not, so be it, that's my expectation. And if that's the case, it's a control chart. Any number higher or lower, it's a run chart. Now, the Fishbone Diagram, also known as Ishikawa, also known as cause and effect, also known as YY. Whew. Man, if they had a name every PMBOK guide, by the time we get to like PMBOK guide 20, well, I think I'd be dead by then because it's every 5 years they update it. Okay, I'm good. Let's, there's 4 different names for this thing here. So the fish shape is optional. Ishikawa, I believe, was the person that came up with it, or that was maybe a translation to cause and effect. At one point I knew exactly where that name came from. I don't remember exactly at the moment. But the cause and effect, like if we have a cause, what are the effects of that cause? So if we have something happening, I think I'm saying that right. Basically the problem versus the symptom. And the YY, like, well, this is happening because. Now, I'm going to talk about this note at the bottom of the screen to begin with. We can use 5 Ys to isolate what the real problem is instead of a symptom. So in other words, people might think this is the problem. And really it's a symptom of something else. So if you ask why up to 5 times, typically by the time you get to about 4 or 5, you're looking at what the real problem typically is. And so, as an example, I got a text message this morning from my kid's mom saying, my son was having a headache at school. Well, he didn't text me because, to be blunt, he knows if his stomach's upset a little or he's got a little bit of a headache, he's not going to get a lot of sympathy from me. And not that he would never get sympathy, but it's I don't just go oh poor baby, come here type thing. So I get these text messages, and he's got a headache, and I said, well, did he tell you he was sleeping when I got home from work last night? As a result, he didn't get to bed on time because he woke up and couldn't fall asleep when when we normally do. No, he didn't. Well, my guess is that's why he's got a little bit of a headache, because getting sleep is kind of like eating food or drinking water. If you don't have enough of it, it can kind of make you not feel too well. So so that was I was trying to get to what the core problem was, not a symptom of, as an example. And I basically said, if you pick him up and take him home, or to your house or to my place, either way, he's going to fall asleep. And then when it comes time to go to bed tonight, he's gonna have his sleep messed up again. So we just keep perpetuating this cycle. And she said, I know. So, so that's an example of, peeling back a layer. Is that the problem? No, that's still a symptom. Peeling back a layer, is that the problem? No, that's a symptom. And usually at about 4 to 5, you've got to where the core problem really is. Now, a couple of things here we can do with this, and the fish shape is optional. Proactively, we could use this to try to isolate what could cause a problem. Could cause. Like as an example, we're getting ready to launch a new digital platform, and our current learning management system and our shopping cart, they just don't talk well together. They really don't talk at all. And it creates a lot of tech support. So we have the potential to have everything in one system. And I really was wanting to do that. And the more I started looking at how the layout possibly was going to be, I thought, I can't do that. And my GM said, why? And I said, because people that would take a class through somebody else that uses our book would be coming to our website and see classes that we're selling. And I've never had a training company customer say, you're trying to take my students, because I've always had a real clear, here's online content, here's the shopping cart, just because of how the systems didn't work together. So I proactively basically said, okay, let's talk through this. I don't see how, and yeah, I know there's some ways I could do it, but it complicated it trying to make it to where, okay, if somebody logged in, they couldn't see my classes and physical products, that they could just see the exam sim app. We felt it was better in the long run to say, let's have a separate shopping cart website where people can buy things. Let's have a separate digital platform where they can buy digital self-paced things and access self-paced content. And behind the scenes, we can have a shared user list, if you will. In other words, single sign-on between the systems. And so proactively, what I was trying to do was make it to where I didn't alienate corporate and training company customers by having a new system. Well, your new system is awesome, but it does this which your old system didn't do, and I'm not going to send my customers to you to have you take them. Good point. So, so that would be an example of proactive. Now, reactive could be where I could go, okay, why don't these systems talk? And like I could say it's a software defect. Well, okay, is it a requirement thing? Is it a testing thing? Is it a design thing? Is it an integration thing? And technically, I could probably play requirements, integration, and design. I could probably play all three. Now, I've got some detail on requirements, so I'm going to elaborate on that here. So there is a single sign-on plugin for my learning management system and my shopping cart. Technically, it's 2 plugins. You put it on one on each system, and then you set them up to talk. What I discovered is that is not how how it's set up, how it works, is not how most consumers consider single sign-on to be. So even though technically I could go, well, your account here works there, or your account there works here, what had to be done by the user to make it work did not align with, like log on, with your Facebook, LinkedIn, Twitter, Snapchat profile type thing. So reactively, I could say the requirements were just not there with that plugin, as an example. So reactively, you could say what is causing a problem. Proactively, you could say what could cause a problem.